August 6th marked a pivotal moment as the James Webb Space Telescope unexpectedly shifted into emergency observation mode, its focus directed at an enigmatic comet that, by all accounts, should not exist. Rather than the expected sight of a dwindling ice ball, Webb's telemetry for 3I Atlas unveiled a profound chemical enigma. Its expansive coma was saturated with an unparalleled concentration of carbon dioxide, alongside metallic nickel, yet completely devoid of any detectable iron. The experts who initiated this emergency override now concede that the retrieved data is alarming. This object is no ordinary interstellar visitor. It defies every known astronomical principle. As more data emerges, the implications become increasingly profound. The fundamental question arises: is 3I Atlas a natural celestial body, or is something altogether different hurtling towards us? The stakes, undeniably, have never been higher. At 2:11 GMT, an urgent communication pierced the quiet of the Mission Operations Center. Marco Macchi's voice, sharp and concise, conveyed critical updates from ground-based telescopes. 3I Atlas was accelerating, and its spectral analysis unexpectedly revealed the presence of metals. There was no time for deliberation. Within 6 minutes, the command sequence for an override was uploaded to the James Webb Space Telescope, pausing all scheduled observations. For the first time in years, Webb's primary scientific agenda was set aside by an urgent directive. This was no routine target of opportunity. Such observations are typically scheduled weeks in advance, debated by committees, and assessed against the costs to other missions. This instance was different. The override request ascended directly to the project scientist's desk, requiring unanimous approval due to the inherent high risk. Webb's operational schedule is a delicate dance of orbits and fuel, where every minute is invaluable. A single misstep, a solitary miscalculation, could cost the world's most powerful observatory a week of scientific data, or worse, compromise a critical subsystem. However, the observation window for 3I Atlas was rapidly closing. The comet's trajectory was shifting hourly, and its coma was expanding with volatile gases and, remarkably, metallic elements. Michel swiftly took the lead, utilizing ESA servers to precisely calculate the coordinates. The NIR spec instrument needed rapid slewing, locking onto the target and commencing spectral data collection before the object moved beyond range. At 2:17 GMT, the command went live. Webb pivoted, its sensors humming in unison, as ground teams meticulously monitored the telemetry stream for any sign of error. In the control room, every eye tracked the data pipeline. The initial packets arrived uncalibrated, but already indicated that the core of 3I Atlas was intensely luminous against the background. The shift log simply recorded: TU override 3I Atlas, 6 August, 2:17 GMT, NIR spec. Yet, this concise entry belied a frantic scramble that tolerated no error. Fewer than 4 such overrides had occurred since Webb's launch, and none for an interstellar object. The tension did not dissipate with the data's arrival. It intensified. The initial observations captured by Webb would challenge every existing assumption about the nature of a comet. But the profound chemical revelations were yet to be fully understood. Carbon dioxide spectral lines dominated the observations far sooner than anticipated. At 6 astronomical units, well beyond Jupiter's orbit, where sunlight is weak and most comets are quiescent, 3I Atlas was already actively expelling gas in sheets of material. Tests had previously detected the first indications: a faint, persistent brightening, not merely a transient flash. Gemini South subsequently confirmed these findings, observing tails extending like ghostly appendages days before the object even crossed Saturn's orbit. This behavior is utterly atypical for comets. In our solar system, such activity usually begins closer to the sun when water ice starts to sublimate. Here, the primary propellant was carbon dioxide, measured by Webb at 8 times the abundance of water. The carbon dioxide to water ratio was an astonishing 8:1. In comparison, typical comets rarely exceed 0.7, and even 2I Borisov, the previous interstellar visitor, registered around half that, a truly anomalous figure. The NIR spec instrument distinctly captured the NU3 band at 4.26 microns, a strong, broad, unmistakable signature. Water was also detected, but it appeared as a minor component. The gas wasn't just present, it was vigorously expelled. Production rates indicated that carbon dioxide output was 8 times that of water. Dust was almost entirely absent, resulting in a thin coma and a faint ethereal tail. However, the gas itself was undeniable. Every cross-check, including data from Gemini, HST, and SphereX, corroborated the findings. There was no calibration error or missed background to explain away the numbers. They were irrefutable. Bryce Bolin, a longtime researcher of interstellar messengers, stated simply that every interstellar comet is a message from another star system. By studying its light and color, we begin to unravel the diversity of worlds beyond our own. But this particular message is perplexing. A body that awakens in the extreme cold of deep space, spewing carbon dioxide as if from a hidden vent. The chemical composition points to an origin fundamentally unlike our solar system, perhaps a world where water is scarce and carbon dioxide is the dominant ice. Or it might signify an unprecedented process that necessitates a complete reevaluation of how comets form and perish. The growth rate of the tail itself astonished the observing teams. In a matter of days, it stretched for hundreds of thousands of kilometers, propelled by gases that should not be active so far from the sun. The physics simply doesn't align. The ratios deviate from all known comets, even the most unusual ones. And the more the teams investigated, the more the numbers defied reconciliation. But this was not the most bizarre discovery. Webb's spectrum harbored even deeper secrets. Signatures began to emerge that would send shockwaves through every established model of comet formation. Nickel lines appeared in the spectrum almost immediately after Webb locked onto 3I Atlas. Initially, the team suspected a calibration glitch, a stray instrument artifact, or a cosmic ray impact. However, the data remained steadfast. Nickel eye transitions were unequivocally clear, visible across the ultraviolet and near-infrared spectrums. The numbers were unambiguous. At 3.8 astronomical units, the nickel production rate already exceeded 10 to 21 atoms per second. By the time the comet approached 2.85 astronomical units, that figure had jumped another order of magnitude. Yet the truly shocking revelation wasn't merely the presence of nickel, but what was conspicuously absent: iron. Iron eye lines were nowhere to be found. Even with the Very Large Telescope's UVES instrument operating at a resolving power of 80,000, the spectrum in every iron channel remained flat. The upper limits for iron were astonishingly low. Nickel outnumbered iron by more than 40 to 1. In every meteorite and comet ever examined, nickel and iron are invariably found together. Here, iron was a ghost. This is highly abnormal. In solar system comets, the nickel-to-iron ratio closely adheres to cosmic averages, approximately 1 part nickel to 15 parts iron, give or take. The previous interstellar visitor, Borisov, conformed to this rule, but 3I Atlas shattered it. Imagine discovering a gold ring with no trace of copper or silver. That illustrates the magnitude of this anomaly. Spectroscopy teams at the European Southern Observatory and the Webb Control Center meticulously reviewed the data line by line, checking for contamination, misidentified features, and solar background interference. Every cross-check held. The nickel lines at 3415, 3524, 3525, 3769, 3783, 385, and 3858 angstroms were all present above the noise floor. The signal-to-noise ratio for the strongest features exceeded 30, yet iron was completely absent, not a single blip, in the core, coma, or tail. Laboratory data offered a plausible, albeit speculative, explanation. Nickel carbonyl, specifically nickel carbon monoxide 4, a molecule so volatile it can vaporize at 43 degrees Celsius. Under specific conditions, carbon monoxide-rich ices, a small amount of metallic nickel and ultraviolet radiation could form nickel carbonyl monoxide 4, which might then drift into space and break down under sunlight to release atomic nickel. However, its iron counterpart, iron carbonyl monoxide 5, is significantly less volatile. Its vapor pressure is low, its formation sluggish, and its spectral lines are silent. This could potentially explain the absence of iron if and only if the parent body originated in a world where nickel was abundant and iron was somehow excluded. No solar system comet has ever exhibited this pattern. The near-infrared spectroscopy team internally noted this finding as unprecedented in any volatile-rich body. The more the team scrutinized the numbers, the more the established models unraveled. What kind of formation environment could produce such an extreme ratio? Is this a never-before-seen chemical signature or something more deliberate? The chemical enigma only deepened as more data became available. But the compositional oddities were not the end of the strange phenomena. The manner in which 3I Atlas moved was about to provoke even more profound questions. Acceleration curves began to raise eyebrows even before the chemical data was fully downloaded. Pan-STARRS analysts, tracking 3I Atlas across a network of telescopes, observed its trajectory bending away from the expected path. The numbers were unequivocal. In just 72 hours, 3I Atlas stunned astronomers. Its velocity jumped by 0.12 meters per second squared, an acceleration no comet this size should manage. Imagine an 11-kilometer-wide cruise ship suddenly picking up speed without engines or wind. Gravity alone couldn't explain it. Even stranger, the movement wasn't smooth. Each update showed sharp little jolts layered over the main acceleration, like something flickering on and off inside. Pan-STARRS checked for software glitches, but the raw data held. The anomaly was real. The light curves added another layer. Observations from Gemini South and TESS showed a perfect rhythm, a 7.2-hour cycle of brightening and dimming, sweeping like a cosmic lighthouse beam. That's not how natural objects behave. Comets tumble chaotically, slowing as they vent gas. But 3I Atlas kept its timing steady even as activity ramped up. Some tried to model it as an oddly shaped rock spinning in sunlight. The fit didn't work. Others suggested broad, reflective surfaces, more like panels than dust. The resemblance to Oumuamua's unexplained acceleration was impossible to ignore. But this time, the signals were clearer, sharper, more mechanical. Then came the metallic riddle. Spectroscopy revealed nickel without iron. In nature, these elements are forged together in the hearts of stars. To find one without the other should be impossible, unless something had separated them. On Earth, that's an industrial process. In space, it's a mystery. The implications set off debate worldwide. Data archives filled with plots of the acceleration. Social media and preprints buzzed with speculation. Some argued exotic chemistry, maybe carbon-rich ice driving unusual jets. Others floated more radical ideas. Sails, thin structures built to ride starlight. Harvard's Avi Loeb pointed out the obvious. Every natural model struggled to explain all the anomalies at once. NASA's Planetary Defense Office quietly flagged 3I Atlas as a high anomaly. Not a threat, but a wild card. What's certain is this: 3I Atlas doesn't fit any box we've built for comets or asteroids. Its movements are too sharp, its light too rhythmic, its chemistry too strange. Is it a rare cosmic fluke, born in some alien nebula with rules we don't understand? Or could it be something constructed, designed for a purpose we've yet to grasp? The deeper the data goes, the stranger it becomes. And the next round of observations may finally force astronomers to face a possibility they've long resisted.